Hey everyone, welcome to another training video at our official channel of Cloud 360. This video is about Active Directory Certificate Services, where we will understand the importance of the Active Directory Certificate Services in enterprise networks. My name is Navneet Kumar and I'm a Microsoft certified trainer. Well, let's get started with the introduction to the ADCS. The Active Directory Certificate Service is a solution from Microsoft which provides the customizable services for creating and managing the public key certificates. These certificates are essential for securing communications and verifying the identities within enterprise environments. The Active Directory Certificate Service enables organizations to implement the public key infrastructure to support encryption, digital signatures, and secure authentication. It plays a critical role in ensuring the data integrity, confidentiality, and trust across the networks. By issuing and managing these digital certificates, the ADCS helps organizations protect the sensitive information and maintain the compliance with security standards. It supports a wide range of applications, including secure email, network access protection, smart card logins, web server certificates, and many more. In a nutshell, the Active Directory Certificate Service provides a full fledged solution to the enterprises to set up their public key infrastructure. Well, let's talk about the types of certificate authorities we can configure. The certificate authority in Active Directory Certificate Service can be configured as either the standalone or enterprise certificate authority. A standalone CA operates independently of the Active Directory and is suitable for the small environments or workgroup environments. It requires manual certificate requests and the approvals, making it ideal for offline or isolated systems. On the other hand, the Enterprise CA is tightly integrated with the Active Directory. It allows the automated certificate enrollment and the policy enforcement. It is designed for domain joined environments where centralized management and scalability are essential. Enterprise certificate authorities support features like auto enrollment, certificate templates, and group policy integration. This makes them the preferred choice for most enterprise deployments. As far as we discuss about the architecture of the certificate authorities, we have the single tier or two tier options. In single tier, we have a single certificate authority server that issues the certificates, but there are chances that this root CA or the primary certificate authority may compromise. For security reasons, we go with two-tier architecture. This enhances the security and scalability by separating the roles of certificate issuance and the root trust. The root CA is the top level authority in the hierarchy and is typically kept offline to protect its private keys. It is used solely to sign the certificates of subordinate certificate authorities known as issuing CAs. The issuing CA operates online and handles day to day certificate requests, issuance, and revocation. This separation ensures that the root CA remains secure from any potential network threats, while the issuing CA can efficiently manage these certificate operations. This architecture allows organizations to maintain a high level of trust and security while supporting the operational needs. A visual diagram shows the root CA at the top, which is connected to the issuing CA or subordinate that is delegated to issue the certificates by root CA. Well, now let's talk about the advanced certificate concepts. In this list, the number one is Certificate Revocation List. The CRL is a critical component of certificate validation in ADCS. It is the list maintained by the certificate authorities that contain the certificates that have been revoked before their scheduled expiration date. Certificates may be revoked for various reasons, such as compromise of the private key or changes in the status of the certificate holder. Clients use the CRL to verify the validity of the certificate during the authentication process. The CRL is published periodically and must be accessible to the clients to ensure the proper validation. Failure to access the CRL can result in authentication failures or security risks. Proper configuration and regular updates of the CRL are essential for maintaining a secure PKI environment. Next is CDP and AIA. CDP stands for CRL Distribution Point, whereas AIA stands for Authority Information Access. These are the certificate extensions that provide the critical information for certificate validation. CDP specifies the location where the CRL is published. This allows the clients to retrieve the list and verify the certificate status. AIA provides the information about the issuing CA, including the location of CA certificate and online certificate status protocol OCSP responders. These extensions are embedded in issued certificates and are used by the clients during the validation process. Proper configuration of CDP and AIA ensures that the clients can access the necessary information to trust and validate the certificates. Misconfigured or inaccessible CDP and AIA locations can lead to validation errors and security issues. In a demonstration shortly, you will see how to set up the CDP and AIA for your certificate authorities. Well, we will look into the deployment demonstration where we will deploy the root CA. Number one, we will install this Active Directory Certificate Service role as a standalone certificate authority on our server. Then we will introduce another certificate authority that will be our issuing CA. In this way, we will set up the two-tier architecture with root CA and issuing CA. Finally, the certificates are issued and tested for the domain users and services to verify the functionality. So without any further ado, let's get started with the demonstration. To set up a two-tier Active Directory Certificate Services architecture, we will start with the deployment of the root CA, which will be our standalone certificate authority. For this, we will first enable the network discovery on this system so that this computer and its services can be discovered by the neighbors and it can discover the neighbors as well. For this, I will turn on the network discovery on the current profile. We'll select turn on network discovery. As you see, when the network discovery is on, this computer can see other network computers and devices and is visible to other network computers as well. Finally, we will click on save changes to save these changes on the system. To install the Active Directory Certificate Services, we will move to the Server Manager, wherefrom we can click on Add Roles and Features. We'll go with role-based installation on CA Server 1 and select the role, which is Active Directory Certificate Services. We'll add all the required features like the management tools. We'll click Next and then we'll select the certificate authority as a role service and click Installation. It will take some time, so I have paused the video and resumed to save the time. We'll click Close once the deployment is completed. Now you will notice that there is an exclamation mark. We will go to this notification center and click on this exclamation mark to configure the Active Directory Certificate Services on this system. We'll start with the local admin credentials, CA Server 1 Administrator, and click Next. This is the certificate authority role. We'll select it and click Next. This is standalone certificate authority that I will configure as root CA. After all, we are going to take it offline after making the subordinate or issuing CAs after this. So let's go with root CA and create a new private key as we do not have any existing. We'll select the appropriate hash algorithms like cryptographic providers we have in the list and the hash that we want to use like secure hash algorithm, and the key length we can decide according to our application's requirement. Then we will click next and provide a name to this certificate authority. For example, Contoso root CA, and this is the common name for this certificate authority. The validity for the certificates provided or generated by this is for 5 years. We can increase or decrease it as per our business and technical requirements. Finally, we can click configure. This also takes some time. I will pause and resume the video to save this time. We'll finally click close after the configuration of the root CA. Our root certificate authority is now ready. We can see the management tool, which is under the tools, the certification authority management tool, to see the service. This is Contoso root CA and is in green color, which is active. Now we can go to the properties to look at the properties of this certificate authority. This is the root CA certificate. We can export this certificate so that we can store it into the trusted root of the clients. Here are the extensions that I was discussing in the explanation about the CDP and AIA. This is the CRL distribution point, which provides the location which clients can use to locate that whether the certificate is valid or has been revoked. For this, I will provide my subordinate CA that I will be promoting later on, which is not there right now, but yes, of course, right after this, we will be promoting the London Server 1 as our issuing CA. On that URL, I have appended few things at the end like CA name, CRL name suffix, delta CRL allowed, and finally dot CRL, the certificate revocation list. We can click OK after providing this path for the certificate authority, which will act as a CRL distribution point, which will be our London Server 1. We can click include the CDP extension of issued certificates. So this certificate or any certificate issued by this CA will have the CDP and CRL which clients can use. I will not restart this service because I will configure the AIA authority information access as well for our certificate authority. For this, again, I will click on add. Will provide the location of AIA server, which is going to be http londonserver1.contoso.com/cert data. And after this, will provide some variables like the server's DNS name, underscore, CA name, certificate name, and at the end, we'll add the extension as CRL.CRL. This is the final path for authority information access and include in the AIA extensions of the issued certificates and restart this service. This is how we can configure the extensions on our certificate authority servers so that this additional info is available within the certificates issued by these certificate authorities that the clients can utilize to validate that whether they can trust the certificate provided by any client or not. It might be possible that the certificate provided by the client is revoked. Now we will go to all task and click publish for the revoked certificate list over here. It can take few seconds. You need to wait for few seconds and then it populates this window where you can publish this CRL and click OK to create or publish a new CRL to it. I will go to the properties again and will export the certificate of this root CA so that the certificate can be added to the trusted root certificate of the clients so that the certificates issued by this certificate authorities can be trusted. For that, I'll go to the details and will export this certificate using its public key. So this is the CER canonical encode reader extension through which I can export this certificate along with its public key and will export this finally to some local location. Then I can put it into a network share which can be used by the clients later on. I can go to the C windows and system32 location where we have the certificates data stored. This is the cert SRV. This is the certificate service from where I can access the cert enroll and the certificates, which is, let's say, Contoso root CA CRL distribution point, the CRL location, and the CRT. This is for CA server 1 Contoso root CA CRT. I will take these certificates and put them to my issuing CA, which I will promote shortly, London server 1. So this is London server 1, and administrative access I have used the C dollar. This is the root CA certificate, and the other one that I have put are these two certificates also. Later we will utilize these certificates to configure our subordinate CA. Now we move to add roles and features on our server, London server 1, to configure it as a subordinate CA. We'll install the Active Directory Certificate services, and the two role services I will install from here. Number one is the certificate authority, of course, and the other one is going to be the certificate authority web enrollment, which provides a web interface to the clients to request a certificate or the other details like renewing the certificates or working with certificates. The clients can use this web interface. Finally, we'll install this and click close. Now we'll go to configure the Active Directory Certificate service on this machine. As an enterprise administrator account I'm logged in with, certificate authority and the certificate authority web enrollment roles to be configured. It will be an enterprise CA and I will configure it as a subordinate CA. As I click next, it asks me to create a new private key or to use the existing one. I will go with a new private key. I can select the hash algorithms from here and the key length. Again, I'm going to select the 4096. Next, then I will select the name for it. This is Contoso issuing CA. I can either send the request to the parent CA directly, or I can save this request and can utilize it later. This is saving the certificate request to the file on the target machine. In the C drive, this will be stored. I will click next. We'll provide the location for the certificate database and the log files. Can review all these settings and will finally configure this certificate authority. Well, now it is time to use the certificates of the root CA First of all, I'll use this root CA certificate and install on this machine's trusted root certificate authority so that any certificate issued by my root CA can be trusted. I will select place all certificate in the following store and my trusted root certification authority as the store for this certificate. We'll click finish. From now onwards, this server can trust the certificates issued by the root CA. This is the Contoso root CA CRL. I can export this certificate. So I can right click and copy it and put it to the inetpub www root and create a folder here. This is the cert data. And I will paste this certificate in this location. This is the Contoso root CA CRL. Now I will copy this another certificate, London server 1.contoso.com. This is the request file which was generated and saved when I configured this system. I will take it to my root CA so that I can utilize this file on that target computer. I will put it here to the C drive of my root CA. I have now switched to my root CA so that I can delegate my subordinate CA to issue the certificates. For this, I will submit a new request on my root CA using this request certificate which was generated with the extension as you see .req, and will submit this. Once this is done, you can go and check the pending requests that there should be a request from the issuing CA and the requester name. I can now issue or deny. I have issued this request, which means that I have configured the server as my subordinate CA. I will export this certificate. With this cryptographic message syntax standard, PKCS will include all the certificates in the certification path if possible. We'll check this box and click next to export this certificate that I will use on my issuing CA later. This is the location of my issuing CA, London server 1 and $, and this is going to be my certificate export or exported file. I will switch to my issuing CA, and on the issuing CA, it is time to launch the certificate authority and configure this as a certificate authority server. This is Contoso issuing CA, and as you see, the black dot shows that this certificate authority is still not delegated or is not running the service. Now I have the option to install the CA certificate, and this is the sub CA, the certificate exported from our root CA. This certificate has been stored. Wait for few seconds. As soon as you have installed this certificate on your subordinate CA, then you see that there is the option under the all tasks to start the service of this certificate authority as an issuing CA. And as soon as you start this should turn into green, that the certificate authority is ready to issue the certificates. Now we can see the issued certificates from our Contoso root CA, and finally we can take this root CA offline as our issuing CA is ready to deploy the certificates. In this way, we save the private key of the root CAs by taking them offline. Their keys do not compromise, whereas the certificates are trusted in the enterprise network. We can go to the group policy to export this certificate and load it into all client machines as a trusted root certificate, so that all the clients in the domain can start trusting this certificate. So for this, I have selected the default domain policy GPO. You can create a custom GPO and link it to the appropriate level. I'm doing it domain wide. I will go to the security under Windows settings under computer configuration and will select the public key policies. Under the public key policy, we have several options, including the certificate, service client auto enrollment, trusted root certificate authorities to configure. So I will click import on the trusted root certificate authority so that I can add this certificate of the root CA as the trusted root certificate authority for all the clients in this domain. We'll select this location of London server 1 where I have this root CA certificate which was exported using that public key of the certificate authority server or our root CA, and I have added it here. Now we can update the group policies or wait for the refresh interval of the group policy cycle. As soon as the group policies will be updated on the clients, this root CA certificate will be added to their trusted root certificate authority. This import is now successful. We can close this window. We can now update the group policies on the clients. The certificate will be there. Well, this brings to the end of this demo.